Michael Steinbacher, Plasma-Catastrophist Geology, Revisited. Revisited and presented by Electric Universe Eyes, August 2018. For several years, Michael Steinbacher studied the geological formations of the American Southwest in the field. He has compared the standard and alternative explanations with what he sees, and has noted correspondences and anomalies. The context of his study is the physical interpretation of globally occurring themes of ancient legends and art, the observed properties of plasma behavior in laboratory settings, and a plasma-catastrophist theory of the recent geological history of the Earth. Michael's presentation will show excerpts of experiments and photographs of formations that appear similar. Of special interest will be an experiment of dark mode bipolar plasma discharge above a non-conducting substrate with dolomite and clay dust sifting down over a channel of flowing water and acting as a river running through. Photographs and maps will be presented that illustrate the facility of this model. Due to a sudden illness, Michael Steinbacher could not present at the EU 2015 conference. Andreas Ott gave the presentation Michael had intended to give. Ott, on short notice, filled in for Michael. While he did the best he could, there were several technical glitches that combined with Ott's natural language not being of English, which left many a commenter of the original video asking for an alternate source of this presentation and material, one that is timely and easier to digest. Sadly, Michael passed away in July 21, 2015. To honor the late and great Michael Steinbacher, Electric Universe Eyes narrates a transcribed and slightly modified rendition of that derived from Ott's presentation at EU 2015. I will have you imagine that the following words are coming from the mouth of the late and great Michael Steinbacher himself. Let's begin. We start this talk about catastrophic geology with a legend. The reports we have from various cultures, it's not just one report, it's several reports, making it hard to dismiss. The picture painted by all of these reports are as follows. There was a time of darkness. There was dust, so thick you couldn't see. There were winds so fierce you could not stand. Rocks were falling from the sky, sometimes the size of trees. Also, oil and gravel were coming down. Rocks mingled, so they called it, with the river of fire. It was a time of mountain building and removal. The kind of agent causing these catastrophes was the planet Venus, the comet Venus, as it was popularized by Velikovsky in the book Worlds in Collision. The EU model has a different set of assumptions from the standard model. The aim here is not to discuss those assumptions, but focus on the explanatory power of the model. This is Shiprock, close to the Four Corners area, a beautiful photo by Michael Steinbacher. Shiprock is assumed to be the throat of an ancient volcano that, through millions of years, erosion has exposed the basalt dikes connecting to shiprock like spokes. From a view above, we see three primary spokes with the three secondary spokes in between, all pointing to shiprock, and the outline creates a hexagonal shape. Digging into the geology of the Southwest, the first example is the Grand Canyon. The Colorado River runs through it. It is about a mile deep. The north rim is roughly 1,000 feet higher than the south rim. The south rim is roughly 1,000 feet higher than the surrounding area below. The standard model has the Colorado River physically eroding the Colorado Plateau while the plateau is rising. In this model, the river always managed to erode just enough that the rise was counteracted. Why didn't the river go around to the south since the rim is 1,000 feet lower? That's an odd model. Rivers follow gravity and, very similar to electrical discharge, follow the path of least resistance.
Some in the EU community
propose the Grand Canyon was created by a sizable thunderbolt that we cannot begin to imagine today. Michael's model proposes a time of mountain building while the Colorado River was already there. It's a process of aggregation of material. The material is, of course, provided by close encounters of cometary, planetary action, basically filling the air with a lot of material in the atmosphere available for the aggregation. The river, which was already there, prevented where the aggregation was flowing. In this model, the canyon is growing around the river, thus creating the canyon itself. It's a different model. It's not so much about erosion, it's about aggregation and prevention of aggregation. And electricity might have played a big role in the creation of the layers that we see. Later on in some of Billy Overton's experiments, indications that this might have been the case through active and observable layering, that a kind of electrical sorting might have happened. Here's a more detailed map. It seems that as for a post-process following the initial creation, something accentuated and expanded and developed the side canyons of the Grand Canyon. This might very well have been done through a charge flowing through the river and through the canyon. If you look at those canyons and the available drainage area, there is not much drainage available. Let's say an erosional pattern that doesn't end on the south side is even more questionable because the landscape declines in the elevation down to the south. Water would have gone the other way, so therefore Michael suggests that after the canyon was created, some electrical current charge went through it and helped with the development of the scalloped walls, as they were accentuated and those side canyons widened. This electrical charge might have been responsible for the schist and granite at the bottom of the canyon, because if the charge goes through there, it's constructed in the narrow space. The current density goes up, and this might influence the material in that tight location. In fact, the model itself contains the ability of electrically creating rocks out of dirt and to metamorphic rocks into different types of rocks. There is some support for this, experimental support. Michael Naya from Colorado has done some experiments about this. He was able to, for example, create pegmatite, a kind of metamorphic granite from dirt, just by running the current through it. By the actual electrical forces active here at Grand Canyon were kind of small compared to what was going on roughly 100 miles north at Zion. This is Zion Canyon. On top we have shale, mud, and below it various layers of sandstone, and at some point Michael thinks the whole area was sloshed, which means it covered with sediment, which then later got cleaned out. This is a map of the area, and you see something very odd here. Do you see all of those lines? What are those? Looks very irregular, as if something came from the south and basically ate the material, eating into and creating those straight lines. As we look deeper into it, it becomes more visible, and the idea is that whatever from the south removed the mud and shale on top and eroded it electrically away. Now we are looking at a satellite map of the area. Look at this color scheme here. This appears as a small area of untouched mud and shale. Here with the light color, that's remnants of the shale, but might have been morphed into more like pottery there. It's clay. It's kind of hardened. It's bare of any vegetation. And down below here, that is the sandstone. So this is what the sandstone looks like in Zion Canyon. Really scratched, at least from the outside, but also from the inside. This is another picture of the area. Notice this odd thing up here? What could this be? Michael thinks that was a remnant of mud and shale which kind of melted before it could be removed, which then kept it in place. Let's have a look at the wider area here. We have Kolob Canyon over here. By the way, this is Zion. Up here, that's Kolob. You can see the straight lines going up. The same thing we have over here, that's Snow Canyon, and it looks like something was hitting this area. Something came from the south, something electrical, and hit those walls. Interestingly, many places just north of those areas show basalt layers and tuff layers. That's just an observation. Look at the wider area, more to the east, again in satellite view. Here we have Zion, and over here practically that's the staircase of the Escalante over here. Still we see that these discoloration patterns and this light continues to the east. The whole area seems to have been hit in this model. So let's continue with Snow Canyon. This is a close-up where you can see what is described. Those lines continue up here. What was that? If you look at it in more detail, would water do that? Probably. If not, the problem is here it goes down. So if water would have done this, we would expect a similar erosion pattern to the north. It's just not there. The standard model has some issues. This is Bryce Canyon in satellite view. There might have been other areas that were not hit head-on or perpendicular, So the effects were minor in comparison, and Bryce Canyon seems to be an example of such region. North of Bryce, you will find a lot of basalt and welded tuff. Another example, this is Cedar Breaks. Again, the same thing, there is a lot of basalt nearby. Here's a picture showing the change in terrain. What you can see here is that because it was only grazed, not directly hit, there's still some sedimentary structure there. It's not that clearly developed, and there's a slight bit of vegetation there, so indicating it was that intense at those places. On the topics of sediments, this is a sedimentary rock map of North America. A lot of the valleys in the southwest filled up with 20,000 feet of sediment. This is a lot. Basically means that we are only seeing the tops of the mountains. The rest is under the sediment. It's hidden. One method of sediment distribution we have already discussed, this electrical removal and then redeposition at other places. Another option, of course, is the sloshing flooding event mentioned before by Michael. When the waters rush to the poles and east-west, depending on what just happened, those waters are injected through the canyons into higher regions, let's say up to 12,000 feet. When the water is running up there, the sediments from the sea, from the continents, they're swept over, is suspended in that water. It then starts to create layers by depositing that sediment, and it's very interesting to see that. It is recommended you watch the so-called sedimentology videos by Colorado State University. They did tests, and looking at this, it seems that when water streams with the given current and the currents change, it always starts new layers, free layers, and they are then developing in the direction of the current. So it's not something like slow deposition in standing water. That might be an option, but it goes like this in several layers in parallel. It's growing. You can have very fast fill-in of areas with this sediment, which looks like it was probably millions of years that it took in the standard model. But those experiments show very clearly that it might have been much faster. Something we can see here in this map. See this circular type structure here. This continues up here going north and down coming back to the islands. This kind of stands out here as some kind of galaxy shape actually. On the Northern American continent, this galaxy shape, as we all know, is a very common discharge pattern. So could it be that some electrical event happened over North America which created those mountain ranges? It's certainly an option. Let's look a little deeper here. This is terrain mode of the centerpiece. If you look into this, some kind of roundish structures here seem to stand out. Let's get deeper into those. The basic idea is that some electrical event or succession of events created those mountains, removed older ones, and redistributed sediment all over the place. Again, look at those here. 4 corners. That's basically the area where we think it kind of happened. To the right, you can see this smaller inner circle. It stands out. By the way, shiprock is very close to the center of this circle. There seems to be a kind of altering here which is showing up nicely if you look at the rock maps of the area. Seems to be basalt in a ring going around here. This is the so-called 4 blinds of the Colorado Plateau. So the event which Michael has in mind here is like a vortex. Think of a diachotron and instability over this area. That of course means we have vortices within vortices, counter-rotation, but the overall main direction of the main vortex seems to have been clockwise. Also, what's a little odd here is the area around initially didn't fit. The other areas seem to have shown a lot of removal of material, and this area shows an aggregation. The basalt is showing up nicely here as a ring. If you look at those from the standard model, those have a little bit of a problem. There is often no source of the basalt to be found. There are actually a lot of missing volcanoes involved in the standard model. So it's like they're there and then some kind of selective erosion process happens and removes a lot of the basalt in between, and then the volcano, and especially the volcano goes, the stumps and the roots, nowhere to be seen again. This is kind of a strange model, I think. There's also something called welded tuff. Basically, this is also material that came from volcanoes, but it's more like dusty stuff that is welded onto itself, onto another material. Something like this. But also, the welded tuff model in the standard description has a problem because of those sources for the welded tuff are roughly 200 miles away from the deposition. The question remains, how does this material stay hot in the standard model to be actually welded at the deposition point? It's probably what nature does, so they say. I don't know. If you don't have any other option, you might come up with such ideas. But in Michael's model, streams of plasma, or the so-called river of fire from the legends, was flowing over the surface of the Earth, and it could have kept this material, which was in the air, electrically eroded, coming from cometary material raining down on Earth, keeping it hot. So that when it actually rested in the place where it was deposited, it was still in a state that was able to actually weld. This is an example of what the process looks like. Considering the EU model, Michael's model doesn't apply only to welded tuff. It is basically the main deposition process of all the other materials. It may be dolomite, basalt, tuff, sandstone, limestone. It's all being deposited like this on top of already existing obstacles. It is basically the main mountain building process in his model. If you want to find this place, this is at the south entrance to Death Valley. Here's another example. It's south of Pahrump. The dark gray is dolomite. The red is welded tuff. Light gray is shale. If you want to find this shot, it's from Highway 170 looking northeast from the 127 sign and looking up at those structures in the middle. Before, when there was mention of four corners, we had aggregation. That imagery didn't fit well, but later on he concluded that this is actually deposition, clockwise deposition from material that was removed at other places like Canyonlands, Moab, and areas around it. To the area in question, it is basically the Grand Mesa, the Gunnison River, and part of San Juan's. That's, by the way, a Gunnison River with the Black Canyon. The Grand Mesa is about 10,000 feet high. The standard model would like to see some kind of volcanoes in the area to provide for that basalt, and we would be looking for it north of the Gunnison. The area at the highest peaks is roughly around 11,000 feet, and between the Grand Mesa and this area, there is a valley which has a height of 5,000 feet. So, in order for the standard model to work, you would have to remove 5,000 feet of basalt without a trace to get it there. Think about that. Also, where is the volcano? That's the area where they are looking for it. I don't see it. We're still looking, even looking a little deeper. There are peaks there, but nothing that look like a caldera or something relative. Anyway, this is a missing person case. We are delightful for any hints on where to look for it. Another topic visible here at the Black Canyon are quartz veins. The standard model attributes their creation with ongoing hydrothermal processes. The electric universe model, which is kind of catastrophic, doesn't have that amount of time available in those areas, so there is a replacement process actually needed in some way. We think it's also electrical. Look at this, for example. This picture was shot at southeast of Domeland, which is just south of Yosemite. It looks like feathered discharge of a Tesla coil. The idea is that quartz veins are aggregation accumulations from charge running through the earth, but this might not also affect silicon dioxide. Very often we find gold in those areas close by those quartz veins. Maybe there's also some kind of transmutation involved. Also, diamonds show up. Why do we think this kind of model has any merit? Well, as of a few months before the original video in this presentation was made, there was some very delightful similarities in this model and laboratory experiments done by Billy Overton. It shows that the results of this experiment allows for this type of model to work. It's an option to strongly consider, and I recommend you watch the videos. It's really interesting what happens there. So here are some still images of this work. And what did he do? He had an anode, cathode, and electrodes being there, and he let material rain down from above. So think about a cometary interaction with the tail dumping material into the atmosphere. First thing we see here is that we have more aggregation to the left than on the right. On the right, we have much less aggregation. Prevention of aggregation is observed. Here's another example with a different mix of material. It more or less looks like the same deposition, but even stronger are those areas where there is no aggregation visible. This one here looks pretty much like something we can find on the moon. The riles on the moon might look like this. This is a different model. It's not so much the model of excavation. It could also be something like prevention of aggregation, and it's an idea. This is what came from those experiments and what it makes you consider. Next one here, Billy tried with flowing water. Here in the straight line while material was falling from the sky and electricity was flowing. What you can see here is in the middle between the electrodes, there's much more aggregation. A detailed look shows us what we can see, a kind of scalloped wall. There seems to be a sort of horizontal layering. The material from above was completely mixed, so there might be some kind of electrical sorting going on while it's being deposited. Think Grand Canyon, and a lot of horizontal layers are there. This is kind of a control experiment. Put electrodes to the side of the river. We still see major aggregations at the water flow, not so much around the electrodes. On the other side, we have what we would expect, simply deposition. Next one here, same thing. This time we have water flowing. It was meandering under this different test. Here the scalloped walls are nicely visible. Think if you put that to scale, what kind of canyon that would be. There are areas where we have prevention of aggregation. Last slides of those experiments are a control experiment again. What happens if we don't put in electricity? These slides are quite different. To sum it up, the electric universe paradigm is immensely being used. To the tool set of geology and process, there are now a lot more options available. You don't have to resort so many times to "it's what nature does" without a logical answer. The described processes are able to resurface the Earth in a very short period of time. Last but not least, the scenario connects what we find on Earth was with catastrophic myths and legend. We no longer have to dismiss them like the standard model has to.